Lesson 323, completing the square. So here we have a bunch of pictures that shows things that complete one another. We have an avocado with a pit, an avocado without a pit. You put them together, they make a whole avocado. You have garlic and you have bread, garlic bread. They complete one another. We have a donut and a donut hole. They complete one another. But of course, the most important one on this page, Mr. Plotz and Mr. Yassine. Okay, so our objectives for this lesson. 1 is, how do I complete the square? 2, what can it be used for? And 3, how does it relate to a parabola? So our vocab, perfect square trinomial, that is a review and we're going to practice that. Completing the square, it's a process that makes a perfect square trinomial. So that's going to be our goal. That's going to be part of the process. And then our vertex form. We're going to eventually want all of our quadratics in this one to end in vertex form. So our prereq skills, factoring perfect square trinomials. So a is not 1 here. We can go straight to doing the diamond. What multiplies up to 81 and adds to negative 18? That's going to be negative 9 and negative 9. Right? Those are the same numbers. So our factors here are x minus 9 times x minus 9, or perfect square trinomial, x minus 9 squared. Same thing here. A is not 1, so we got to do some multiplying. So we got to rewrite this as x squared plus 12x plus 36. Now we do our diamond. What multiplies up to 36 and adds to 12? And you can imagine, since it's a perfect square trinomial, we're looking for the same number, 6 and 6. So now we're looking at x plus 6 times x plus 6. And remember, you can go ahead and write this as x plus 6 squared right off the bat. But this one does require an extra step because we multiplied by 4, and we have to undo that. So we're going to be dividing by 4 here. Okay, so first to check, see if it divides evenly, and it doesn't. 6 divided by 4 doesn't divide evenly, but we can reduce 6/4. Right, we can divide both top and bottom by 2. That gives us 3/2. So we can reduce these to x plus 3 over 2 times x plus 3 over 2. Same reduction. And now they don't divide evenly, so we shoot it out in front. Shoot it out in front. We get 2x plus 3 times 2x plus 3, or again, you can rewrite it as 2x plus 3 squared. Perfect square trinomial. The next one, we got 4, negative 16, and a positive 16. So what we can do here, we notice that these are all even numbers, and 4 goes into each one of these. So we can factor out a 4 first. I factor out my 4, I'm left with x squared, right? And we're just dividing these technically by 4. Dividing all these by 4. Minus 4x plus 4. Okay. So now my a is 1, so I can go to doing my diamond. What multiplies up to 4 and adds to negative 4? My two numbers are going to be negative 2 and negative 2. So this is going to be 4. We got to bring that 4 down, so 4 times x minus 2 times x minus 2, or skip that step if you choose to, and you can rewrite it as 4 times x minus 2 squared. Ultimately, we want this answer here. All right, so now completing the square. And this is going to be from standard form to vertex form. Okay, so we first notice a is 1. So you don't got to do any simplifying. But the first step I want to do is I want to add this 7 away to both sides. Let's pretend that's a 0. 7 on both sides. So I'm going to have now x squared plus 10x. We're going to leave a little space because we're going to add something here. Equals positive 7. Okay. Now, our goal here is to force this to become a perfect square trinomial. And in order for it to become a perfect square trinomial, we're going to use b. We're going to take 10. We're going to divide it by 2. That gives us 5. And then we're going to square it, which gives us 25. Okay, so we took the 10, divided it by 2, gave us 5, and squared it. Let's see if I could write that a little better. Okay. Then we did 5 squared, and that equals 25. So what we want to add here, fill it in, is we want to put a plus 25. Okay, so that gives us a perfect square trinomial, right? Because if we do our diamond method, what multiplies up to 25 and adds to 10? That's going to be 5 and 5, right? So that'll be x plus 5 squared. So before we go to that step, we added 25 to the left side of the equation. And remember, algebraic principle, what you do to one side, you have to do to the other. So if we added 25 to the left side, we have to add 25 to the right side. Okay, now we want to simplify this out so it could be in vertex form. So we want to factor it. So again, we go back to doing the diamond. So what multiplies up to 25 and adds to 10? Like we said, that's 5 and 5. So rewriting the equation here, that's going to be x plus 5 times x plus 5 equals, on the right side, 7 plus 25, which is 32. Okay. Now I'm going to rewrite that x plus 5 as x plus 5 squared equals 32. And my last step, I want to bring this 32 back so it looks like it's in the vertex form. So we'll have x plus 5 squared minus 32 equals y. And that is in vertex form, right? And remember vertex form, x minus h squared plus k equals y, and a is out of front. All right, next one. All right, so step 1 is the same. We want to first subtract that 2 away, right? We want to make that a 0. Subtract 2 away, subtract 2 away. So we'll have x squared plus 5x, leave some space because remember we got to make this a perfect square trinomial, equals negative 2. Okay, so in order to make this a perfect square trinomial, we're going to take the 5, or we always take b, do 5 divided by 2, which gives us 2.5. Then we want to take 2.5 and square it. And 2.5 squared, if you pull out your calculator, gives us 6.25. So we're adding, I don't think I left enough room for myself, so we add 6.25 here, and algebraic principle, we got to add 6.25 onto the other side. Now to make this into a perfect square trinomial into vertex form. So if we're looking to do the diamond method, you'll kind of start noticing what numbers you need, and it's always going to be that 5 divided by 2, which was 2.5. So if we put 2.5 here, 2.5 here, 2.5 times 2.5 we know is 6.25. 2.5 plus 2.5 is 5. Okay, so that's a quick way to figure out what your factor is going to be. So I know I'm going to have x plus 2.5 times x plus 2.5 equals 4.25. Okay, I'm going to rewrite this as x plus 2.5 squared. Okay, and again, you could have skipped this step here and gone straight to this step that we're doing right now. Equals 4.25. And lastly, we want to bring that 4.25 back to the other side and just rewrite our answer. I'm going to write it off to the side here. I don't have room over there, so this will be x plus 2.5 squared minus 4.25, and that's going to equal y. And that is in vertex form. Okay, so if you go ahead and you plug this into Desmos, you can plug both the standard form in and the vertex form in, see if they overlap, if they match up, and they should. Okay, now completing the square when a is not 1. Right, so that last slide, all the a's were 1. This time the a is 2 and the a is 3. Step 1 is going to remain the same. So step 1, we're going to get rid of the c value, right, and make that a 0. So here we're going to have 2x squared plus 8x, leave your space, equals 7. Now we need to notice, since a is not 1, we got to check to see if we can factor anything out of here. And it looks like we can. 2 and 8 are both even numbers, so we can at least take a 2 out. Remember, you got that space there? So I'm going to factor out a 2, right? And that really just means that you're dividing these 2 by 2. So in parentheses, I got x squared plus 4x. I'm still going to leave my space, equals 7. Okay, I still want to complete this and make this a perfect square trinomial, so we still need to fill in that blank. And that, we're going to do the same thing. We're going to take b, we're going to divide it by 2, which equals 2. Then we're going to take that 2 and square it, which gives us 4. So I'm going to add 4 right here. Okay, but we have to be careful because this step is where a lot of students start making mistakes. Even though we added 4, we can't go straight to adding 4 here because this 4 is being multiplied by 2. Really, on the left-hand side, we just added 8, right? Because 2 times 4 is 8. That 2 gets distributed back in. So instead of adding 4 on the right side, we're actually going to add 8. Now we've focused back on this, and we're going to make this into a perfect square trinomial. So this will be 2, and if you do your diamond, or if you've caught on already, you know it's going to be half of b. But if we do our diamond, what multiplies up to 4 and adds to 4, it's going to be 2 and 2, right? Or you just take half of that. So this will be x plus 2 squared, right? Because it's x plus 2, x plus 2. And on this side, we're going to have equals to 15. So to keep it in vertex form, we want to subtract the 15 back to the left side. And we get 2 times x plus 2 squared minus 15 equals y. And there we have our answer. Now the next one's going to be a little tricky because when we factor, it's not going to be a whole number. We're going to be dealing with some fractions here. So step 1 is going to remain the same. So for step 1, go ahead and add your 7 to both sides. Right, we want to make space so we can complete the square. So we'll have 3x squared plus 2x, leave your space, equals 7. 7. Okay. Next step, we check to see if we can factor 3 and 2, but regardless, we're going to have to make our leading coefficient 1, so we have to factor out a 3. So if I factor out a 3, and remember that just means that we're dividing these by 3. So now if I factor out a 3, let me write this a little lower. If I factor out a 3, and I'm dividing those by 3, that leaves me with x squared plus 2/3 x. We leave a blank because we got to make that a perfect square trinomial, equals 7. Okay, now the steps stay the same. We want to find out this value here. That's going to make this a perfect square trinomial. So we are going to take 2/3 and divide it by 2. And remember, when you're dividing fractions, you got to flip it and multiply. So this is actually going to be 1/2, and we're going to be multiplying this. We multiply across, that's 2, that's 6, and reduce it down. That'll be 1/3. Okay. So we took the term, the b term, divided it by 2. Now we got to square it. And now 1/3 squared. Right. Remember our fraction, our exponent rules. It gets distributed to both of those. So that's really 1 squared over 3 squared, which is 1/9. Okay. So now in here we're adding 1/9, but just be careful when you add to the right hand side, right? Don't forget that step, because this is being multiplied by 3. So we're really adding 3 times 1/9 to both sides of the equation. So if we do the math, 3 times 1/9, multiply straight across, gives us 3 over 9, which reduced down is 1/3. I don't know what this here is. 1/3. So on the right hand side, we're adding 1/3, or 3 times 1/9. Okay. Now we want to write this as a perfect square. And remember the rule. So you can do the diamond method, so what multiplies up to 1/9 and adds to 2/3. It gets difficult when you're using fractions, but just keep in mind that when you take that b term and cut it in half, that's going to be your 2 factors there. Right, so that's a shortcut. And it is going to be 1/3 and 1/3. Right? Or it was the 1/3 we got here. 2/3 divided by 2. So here we're going to have 3 times x plus 1/3, and that's going to be x plus 1/3 and then x plus 1/3. So I'm just going to write it as x plus 1/3 squared. And that equals 7 plus 1/3. Now when we're adding fractions, I'm going to do this off to the side as well. I'll do it up here. 7 plus 1/3. Remember that we need to have common denominators. So if this is a 3, let me space this out a little. If we have 7 plus 1/3, I've got to put this over 1. Now when we add these, we have to have common denominators. So 3 will be your common denominator. Right, between 1 and 3 makes it easy that it's 1. So multiply the bottom by 3, multiply the top by 3, that's 21. So now 21/3 plus 1/3, that's going to give us 22/3. And that's going to be on the right hand side. Mm-hmm. 22/3. And our last step is to subtract it back to the other side. So we're going to subtract 22/3 and subtract 22/3. And our final answer that we get, I'm going to work it out here, is 3 in parentheses, x plus 1/3 squared minus 22 over 3, and that's all equal to y. Okay, so when you go into Desmos and you put the equation in, you'll see that your vertex is going to be negative 1/3, right, or negative 0.3333, and then your y value will be negative 7.33333. Okay, and you can change these into decimals to confirm your answer. Okay, next problem. We have Casey here, who's a diver, and one of her dives is modeled by h of d equals d squared minus 10d plus 5. So the relation where h of d is her height above the water. So let's say this is the water here. Here's our water. And I'm just going to sketch this. I'm not going to make this perfect. And d is the horizontal distance from the platform. So h of d is the height above water. So this is the height above water. And this is the distance from the water. Okay, so use the given standard form to determine Casey's starting height. So starting height just means that we're looking for the y-intercept. And to find y-intercept, we're going to be plugging in 0. Right, so for these values, we'll be plugging in 0. So for d, we're plugging in 0. So we have 0 squared minus 10 times 0 plus 5. Right, so all I did was plug in 0 into this equation here. So I plugged it into there, and I plugged it into there. Simplify this out. 0 squared is 0. Negative 10 times 0 is 0. Plus 5, and you get 5. So when we plugged in 0, we got 5 feet. Okay, and we can go ahead and graph this on. So let's say that's 1, 2, 3, 4, 5. So here she is starting her dive. So when she first starts her dive, she's 5 feet above the water. So now we got to convert the function to vertex form, determine how deep Casey dove underwater. So if we're looking at how deep she dove, so let's say I want to draw my parabola here. So she starts here, she's diving down, you go underwater a bit, and then you emerge. You don't really fly out, so we can't go like that. So you emerge out of the water. So here she would be floating. So what it's asking is, how deep did she go? And we're looking for the vertex here, right? Because the vertex tells us the maximum and minimum. So here we're looking for the minimum that she went underwater. We're looking for the deepest she went underwater. Okay. And to find out, we're going to put this in vertex form. So we have d squared minus 10d plus 5 equals 0. And we're going to use completing the square. We're going to subtract 5. That'll give us d squared minus 10d. We're going to leave some space, right? Because we're going to be completing the square. We're going to make this a perfect square trinomial. Equals negative 5. Okay. We look at our leading coefficient, a. It's 1. So we can go straight to making this into a perfect square trinomial. There's no need for factoring. So we're going to take the b value, which is negative 10. Take negative 10 divided by 2. That gives us negative 5. And negative 5, we're going to have to square. So negative 5. Negative 5, we're going to square it. That gives us a positive 25. So we're adding 25 to the left side, which means we have to add 25 to the right side. Okay, so the left side now we're going to make into a perfect square trinomial. Again, shortcut, take half of that, and that's your factors. Or if you don't trust me, you can do your diamond method. What multiplies up to 25 and adds to negative 10, that's negative 5 and negative 5. So this is going to be x minus 5 times x minus 5. Or I'm going to go ahead and straight to writing it as x minus 5 squared, because I know I'm going to have that twice, equals, on the right side, negative 5 plus 25 gives me 20. And my last step, I'm going to come back and subtract the 20 to this side, which would give me x minus 5 squared minus 20, and that's going to equal y. So now, as the deep she goes, how deep she goes, we're going to take it out of the vertex form. Remember that the vertex is opposite of h and k. So the deepest she goes is 5, comma 20, negative 20. So if I do this at 5 feet, 1, 2, 3, 4, 5, and let's say negative 20 is like down here somewhere. Erase this. So if I draw her path, she goes down there and then comes up somewhere merges there. But I know the deepest she goes, which is the vertex, is 5 feet from where she jumped. She's negative 20 feet. She's below the water.